The aim of this program is to calculate solution for quadratic equation, include airstream, include manip, include CMAS using namespace standard int main. The first step, step 1, variable declaration. So input variables double A, B, and C. These are the coefficients for quadratic equation, and result variables double discriminant of the quadratic equation, double root 1, root 2, double I root, which is the imaginary root for quadratic equation. Step 2, prompt and accept inputs variable, that is A, B, and C. So cout quadratic equation root solver program. So just this will be printed as it is, and cout this line, it will be printed as it is. Cout enter the quadratic equation coefficients A, B, and C. So it will accept the variables A, B, and C. Step 3, set up floating point format for output of the roots. So this is formatting the outputs. So just we do have 4-digit precision. Step 4, check for division by 0 or not. That's quadratic case. In this case, just we check whether the value of A is 0 or not. If f-ups of A is less than 0.000001, that is if the value of A is much closer to 0, that is 0. Since A is 0, no solution in line, \t is not a quadratic equation. Else, the discriminant value power b, 2.0 minus 4 times A times C. That is, the discriminant is equal to b square minus 4ac. Case 1, check the discriminant. If it is 0, it has multiple roots. So if f-ups of discriminant is less than 0.000001, that means if the discriminant is much closer to 0, that's 0, then root 1 is equal to root 2, which is minus b divided by 2a. Cout \n\t, multiple roots, add, just we do have some spacing, set w12 root 1. Case 2, if the discriminant is greater than 0, it has distinct roots. Else if disc is greater than 0.000001, root 1 is equal to minus b plus square root of the discriminant divided by 2a. Root 2 is equal to minus b minus square root of discriminant divided by 2a. Cout. Let's display the roots of this discriminant, the roots of the quadratic equation. Two real roots, so w12 root 1. So this one will displace root 1. Cout w12 root 2. This one will displace root 2. Case 3, if the discriminant is less than 0, two distinct imaginary roots. Else, discriminant is equal to, since it is negative, just will take its absolute value, f-ups of discriminant. Root 1 is equal to minus b divided by 2a, and the imaginary root is equal to square root of discriminant divided by 2a. So the two imaginary roots are root 1, that is minus b divided by 2a, set with 12 plus I times I root, and the other roots, the second root is root 1, set w12 minus I times I root. Build and run. So enter the quadratic equation coefficient 1, enter 2, enter 1. So multiple roots add minus 1. Then build and run. Issue 1, 3, 2. So two real roots add minus 1.00 and minus 2.00. So the third case, one, 2, 3. So the imaginary roots minus 1 plus 1.4142i n minus 1 minus 1.4142